Okay, before starting question, there is more concept left in it that is related to impulse. To mention last record, so impulse is also a part of this chapter, and impulse is not a very big deal to solve. Basically, we are talking about an impulse. So let's suppose if some footballer is going to hit a football, right? So the moment he hit the football, and if we observe that moment in a slow-mo camera, so you observe that the contact time of hitting the ball is very, very short, right? So force is going to be applied on that object for a very short time, just like when ball is going to be hit by a cricket bat or a baseball bat. So basically, the body is going to be in a contact, or force is going to be applied on an object for a very short time interval. So basically, when force, or when we consider the force on an object in a very short time interval, so basically that product of force and the time is known as impulse, right? Because we know that if we apply force on an object, so the momentum of body will automatically change. Let's suppose football is at rest state, someone come and kick the ball, so the momentum of ball will automatically increase because of force. So that's why you need to know about the impulse. So basically, if we want to write the impulse, so impulse is the impulse of force, right, by time for which it acts. Basically, they are talking about the time during which a force is going to be applied. That is the basically the time of contact between two objects. So impulse is very much simple concept, and there is no specific symbol for impulse. We just write a change in momentum. I will show you how it is possible. Let's suppose, according to my definition, equal to the force applied multiplied by the time, or we can say that the time of contact, right? So impulse will be equal to F, and in time, because we need to record the time period, force remains same, that is going to be applied on an object. Time will be different, so we need to record that time period. So impulse will be equal to F into delta T, right? And one more thing, if we divide impulse with time, let's suppose we are having impulse on left hand side and we are having time on right hand side. So if we just simply divide it on the other side, or we can say that pulse is also known as, it will also be equal to change in momentum. Whenever you are going to talk about change in momentum, so that is also impulse, because if you apply force on an object, so there will be definitely a change in momentum of a body, right? So impulse will be equal to F into delta T, or you also write it equal to delta P, that is change in momentum, right? So you need to know about the basic formula. This is our basic concept of impulse, and you need to know about this, that impulse also equal to change momentum, because questions we are having different values, so it help us to solve the question, because we need to know about the formula, that how we are going to apply the formula. So these are two equation to formula to calculate the impulse, right? And one more thing, because we discussed that it also depends upon the direction, right? So let's suppose if a body is moving in forward direction, and when you are going to kick a ball, so you also got some force on your foot also. So that is in the opposite direction. Or let's suppose if two bodies are going to collide, or let's suppose if ball is going to hit a wall like this, so there will also a change in momentum. So change in momentum means their velocity will be different. Like we may write change in momentum mv. It means mass into final velocity minus mass into initial velocity, right? In conservation of momentum, we are adding initial and final momentum, right? But in this case, because we need to find the change in momentum, so we need to subtract the value. So that will give the change, because whenever we are going to find the change, so we need to subtract. Okay. Okay, now let's start solving the question. That will give you a clear picture that how, what are the use of these formula and how we are going to use in the questions. So let's suppose a very first question, which equation for impulse is correct? Okay, these are equations related to impulse. Just consider these equation and try to answer the question. Now let me show you the question. Impulse is equals to ft, impulse is equals to only t, impulse is equals to mv minus mu over t, or into t. Four possibilities are there. Which one will be right?
Option A.
Option A, because we consider impulse will be equal to f into t, and if we are writing in change of momentum, so ft will be equal to delta p, right? That is mv minus mu. So it means option A is the right answer, because that is very clear in our definition and our formula. Okay, a ball of mass 0.16 kg is moving forward at a speed of 0.50 meter per second. Okay, now when you are getting a question of momentum or impulse, so 90% chances was there will be two bodies, right? So whenever you are getting two bodies or mass of two bodies and velocity, so you automatically get this question is related to momentum, right? Okay, so start writing for initial body. Let's suppose a ball of mass 0.16 kg. So let's suppose if we consider this object M1, right? Because we don't know how many bodies are there, so I'm writing M1 is moving forward at a speed of 0.5 meter per second, right? So we consider this speed as U, initial speed. So I'm writing U1, initial speed of object 1 or initial speed of ball. Now a second ball, so now we are getting a second ball, so this will be equal to m2, second mass of second body, is stationary. Stationary means what will be the speed of second body?
Zero. So the momentum is zero.
Yes, because we discussed that a rest object always have a zero momentum, so it means at stationary state the initial speed of second object will be equal to zero. Now the first ball strikes the second ball. The second ball moves forward at a speed of 0.50 meter per second. So basically now we are talking about the speed of second ball. So always focus on the numbers, because that will mix up the formula. So this is V1 or V2? Is it V1 0.50 meter per second or V2?
It's V2 because
It is the speed of second ball, right? Because in question it is mentioned the first ball strikes the second ball and the second ball moves. So second ball moves means the speed of the second ball will increase. So that is V2. So what is the speed of the first ball? So they are talking about V1. So basically extracting the data from the question is very much important, because you know calculation is very much simple. So there is no confusion in calculation, only there will be confusion in writing data. Because if you are not writing the correct values for correct parameters, so you will get wrong answer every time. Because you know the formula is very much simple. We already discussed over here, m1 u plus m2 u2 equals to m1 v1 plus m2 v2. So we are going to use this formula. M1 V1 plus M2 V2. So M1 will be equal to 0 multiply by 0.50, and we know second object is at rest. So when any object is at rest, so complete momentum will be equal to 0. And M1 remains same, 6, and we need to find out the final velocity of first object. So V1 will be and again M2 remains same. And what is the final speed? Okay, M2 V2. This is V2. Final speed 0.5. And after multiplication, I am writing one complete answer for you so that no one will get confused in it. Okay, so 0.16 multiplied by 0.50, that is 0.08 on left hand side, is equals to, this will remain same, 0.16 V1 plus this will be 0.10 multiplied by 0.50, that is 0.05. Now we subtract this 0.05 on the other side and then divide 0.16. So that will be like this. I am writing here 0.08 minus 0.05. That will be equal to 0.16 V1, 0.03, 0.1 is equals to V1. Getting the concept how to solve this type of equation? 0.1
Yes.
0.187 is my answer. 0.187, and we need to round off the value, so it will be equal to 0.19. That is option B. Okay, because normally they write in a round off form, so you will get answer B. Any confusion?
No, sir, I got the same answer.
Okay, nice. Okay, now let's try to solve. Question number 3 is also a same. What is the velocity of the 2 kilogram trolley after the collision? So this will be your homework, question number 3, because that is same like question number 2. Try by yourself. I am writing the correct answer for this. So that will help you to identify that your answer is right or wrong. This is the correct answer for this question number 3. So try to solve it and find the answer. Okay, question number 4. A force acts on a body of mass m for a time. During this time, the velocity of the body increases from u to v. Which equation relates Fm, T, u, and v? Basically, they are talking about impulse indirectly. So which equation will be correct? These are the equations.
Could you show the question again?
This is the question. Question number 4.
I think it's
Okay.
Option B, I think.
Option B.
I think.
Okay. Option B. Okay, basically, the equation is, I am writing over here. We discussed that F delta T will be equal to delta P, and individual, if we are writing delta P, so that will be equal to MV minus MU. So let's suppose if Ft is equals to delta P, so we may also write this equation like this, that F delta T will be equal to MV plus MU. Is it
Yeah,
wrong? It is
it's
also
correct.
making the same concept, right? And if we
Yes.
consider M as a constant value, so we will
Yeah, we
get
can
this
take common.
value. Yes. So M will be common from the minus U. So they are just confusing you by just reshuffling the equation, but concept remains same. So if your basics are clear, so that will be easy for you. So that means V minus U. So C will be the right one. Okay. C is the right choice. Because whenever we are talking about the change in momentum, so change mean we need to subtract. So that's why option C is the right answer. Any confusion?
No.
Okay, so let's move towards the next one. Okay, these types of questions are very much common also in your exams. The question number 2 we discuss, and this type of question. So these type of questions are always repeat in your exams of IGCSE, and in O levels it was included last year in last session. So you will not find any question in O levels past papers, but in IGCSE you will eventually find in different papers. So basically we are having only a single ball, right? So now the main key point for, or we can say that the hint of this question is the direction. So always focus on the direction. If you are getting a right direction, so your answer will be correct. Otherwise you will always get a wrong answer. Okay, so basically mass is 2 kg. Simple. Now we know that there is only a one ball, so we are not going to write m1, m2. So ball approaches a wall at a speed of 3 meter per second. This is a speed when ball is moving towards the wall. If we consider this direction positive, okay, now you can see that ball is moving towards left hand side. But since it's the initial motion of the ball, so that's why I am considering it positive, right? And rebounds at a speed of 1 meter per second. Now this is going to be rebound. So direction will be different. So I am taking this direction as negative, right? Any confusion?
No, sir.
Okay. Because we are not going to write direction in answer, we just need to find the impulse. And we know that in impulse, we never discuss about the direction, that you need to write the direction. So what is the impulse on the wall? So before that, we need to know about the formula of the impulse. We already written over here that F will be equal to delta P,
I think it's B.
or it will be 4 Newton second.
Yeah.
Okay, let's check it out. Okay, so we know the concept that impulse is equals to delta P. So we are going to use only delta P because we know that we are not having value of F, we are not having value of T. So delta P will be equal to mv minus mu, again taking m common because mass remains same for us. So u and delta P is, and the value of mass is 2 kg. Now that is important part. I am writing with a different color, so that indicates that something is important over here. Now we are having two values of velocities, right? And both are in opposite direction. Okay. Okay, so 1 meter per second is the final speed. So this is v, and 3 meter per second is the initial speed. This is right. So when I'm going to write the values in equation, so always consider positive and negative direction. So I consider this one as positive because this one is the initial speed that is moving in forward direction. And I consider this one as negative. So I will write -1 because that is the negative one, minus 3 meter per second because 3 is
Oh,
positive, right? So we are getting minus minus plus. So we are getting 4. So 2 fours are 8 Newton second. We are neglecting minus sign because sign represents you opposite direction. So we only consider uh, what we say that a magnitude. So if we consider
okay.
only magnitude, so we are getting 8. There are two 8, but there is a difference in unit. You observe there is only Newton. This is Newton second. So D is the right choice. Okay.
Sir,
Yes.
I have a question that
If
the
if you change the
impulse,
direction.
no, impulse is like the part when the ball touches the wall. So why does it even have to be negative? It can't go in any other direction. It's just a contact.
Okay. So yes, because that is only a contact, but we know that impulse is also equal to change in momentum because it will change the momentum of a body. So there is very a short time interval in which body is going to hit the wall and then bounce back. So in that short time interval, we consider both directions, forward and backward, because once we said that change in momentum is equal to impulse, so change in momentum means we need to consider both direction of velocities, otherwise we are not able to find the change in momentum, right? So that's why we consider
Okay.
we need if we are having value of f and t, so we definitely find by using impulse equals to ft, but we are not having value of f and t, so that's why we are getting the help of the concept that delta p is equals to mv minus mu, right?
Okay.
So that is only a mathematical problem, uh, because conceptually we know that if we are having a value of f and t, so we always use that formula. And one more important thing, let's suppose if someone asks you that if we change the direction, so in that case also you will get the same answer. Let's suppose in second case, I consider this 3 meter per second negative and this one positive, right? So according to my second method, I'm just writing it to clear your concept because sometimes you got confused that if we change direction, what will happen? So again, you will get delta P is equals to 2. Your final speed will be positive, right? Because now this time we are using positive sign for 1. So 1 minus, now we are using minus with 3. So 1 minus is already in a formula and 1 minus is for the direction. So so again, you are getting minus minus plus. So you are getting 8 because minus minus plus that will be 4. And again, you are getting answer, right?
Yes.
Any confusion?
No.
Okay, so basically this is a concept of momentum and impulse. There are some questions for you, so you may try by yourself because mostly questions are same on same pattern. Questions are different. Like if we consider football, so in other example we consider cricket ball. In some example we consider bat and ball. So format of question remains same. Only the name of the examples are different, right? So that is not a big deal to solve the questions. And this is a complete chapter of momentum. Okay.
Have you shared this already?